Let's begin. Today's November 2nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 2, 8, 18, 19, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A takes a look at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B will take a look at our 3-digit solution, and the Turing machine will let us know how many 1s there are. Are there no 1s? Is there a single 1? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing machine will let us know whether that sum total is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there's a pair of digits in our solution, as in the example 131, or alternatively, there is no pair, but there are 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find a unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing machine does approve of my proposal. Notice that in criteria card C, we are adding up all the digits. So let's go ahead and do that. So 3 plus 1 is 4, and 4 plus 4 is 8. 8 is an even quantity, and the Turing machine does approve of that. So let's go ahead and type that up in our notes and section C. And again, that's that triangle plus square plus circle should be an even quantity. And so what can we say about that? Well, obviously, if you have all 3 digits be even, that will give us a sum total that is even. But you could also have a possibility where 2 of those digits are odd. So when you add 2 odds, that sum total, or that sum thus far, is even. And then you would add another add an even digit to that, giving you a sum total that is even. So basically, we're looking at 2 possible cases. One where the 3-digit solution are all even, or one where you do have 2 odds and a single even. And let's go ahead and test criteria card E. Okay, so again, the Turing machine does approve of my choice of 314, but in this case, notice that in 314, they're all distinct, meaning that our solution should have no pairs. So let's go ahead and type that up in our notes in section E, and we'll say that the solution has no pairs. Okay, and of course we do have those two scenarios where we have the same digit repeated 3 times, or truly having a all distinct solution. And at this point, I'm not sure if there's a way to deduce one versus the other. I'm trying to think of, I will say that, typically you do have an all distinct solution, but, having a repeated digit 3 times is a possibility. So I think the only thing I can say is that if it is an all distinct solution, from the previous conversation, if we're going to have, we can't have an all even solution, because that would mean that at least one of the 2 or the 4 would be copied, meaning there's a pair of them. And that's not possible at this point since there are no pairs. So if it is going to have evens, they're going to be distinct. So basically meaning 2, 4, and an, I can't. Let's see, let's go back. Yeah, you can't have an all even, and they're not paired up. Yeah, you can't even have 2 evens. It would have to be 2 odds and an even. And those odds cannot be paired up, again, because of the no pairs. Yeah, you can't have all even. So so either it's going to be 2 odds and an even, or it's going to be a repeated digit. And let's see. Again, is there a way to figure this out? Yeah, at this point, I still don't see a way to deduce it. So so currently it's 2 odds and an even, or potentially it's the same digit repeated 3 times. Okay, well, that said, let's go ahead and test criteria card D. Okay, so this time the Turing Machine does not approve of my choice in 314. Recall that we are adding the first 2 digits. So 3 plus 1 is 4. 4 is less than 6, but the Turing Machine does not approve that. So that leaves us with the possibility of the sum of the first 2 digits either being equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section D. D. And again, we'll say that triangle plus square should be either equal to or greater than 6. And I don't think we can actually cross out anything because of the equal, right? You could always add a 1 and a 5 to give you equal to 6. And then again, anything above 1 plus, some other digits can guarantee you to have a sum that's greater than 6. Okay, well, we have completed our 3 Turing tests for this round. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing triangle to the number 3. We also did not test criteria card B, letting us know how many 1s there might be. And of course, criteria card D is a little still unknown. It could either be equal to 6 or greater than 6. All right, so again, our current status is that we could have a 2 odds and an even solution, or a single digit repeated 3 times. And so what can we say? Well, if we do have two odds and an even, it would be interesting what criteria card B may relate. I don't think you could have 3 ones, because that would be, it would automatically tell you there'd be no pairs. So I don't think it can be 3 ones. That would make criteria card E irrelevant. And what else? So yeah, we are looking at, and we can't have 2 because we can't have a pair at all. So yeah, so 3's out of the out of contention, and so is a pair of ones. So either the 1 is there or not. So that would be interesting. If there is a 1, then who knows? Maybe the sum of the first 2 would be 6. That would leave maybe circle to be an even. Now, what would happen if it were 6? Well, we could figure out what triangle and square would be, because triangle would let us know between the 1 and the 5, right? And then square would be the other odd. Okay, but what about circle? How would you figure out what circle is, right? Notice that, besides criteria card C, there's nothing really specific about circle. So I'm wondering if circle is going to be forced into something, into its value. And so, yeah, the sum is 6. I wouldn't know how to pick between 2 and 4 for circle. And again, I'm approaching it from the possibility of it being 2 odds and an even. So I don't see how that could be the case. And let's see what else. So one thing, that just kind of popped into my head about the possibility of a repeated digit as like 222. Since we know that the overall sum is even, the only possibility is having all 2s or all 4s. So what would that tell us? If it's all 2s and all 4s, is that enough to say, if I know there are going to be all 2s and all 4s, then I know that there would be 0 1s. But that is a sort of combination of, criteria card C and E. And I'm not sure. I'm always unsure of, once you commence the game, can you sort of make these kind of logical conclusions? And I'm not sure about that. Yeah, because if I have all 2s and all 4s, obviously there'd be no 1s, and that card would become irrelevant. Let's see what else. So yeah, I am leaning towards the 2 odds possibility. But if there are 2 odds, and there is a 1, then it wouldn't be 6. Because again, I would know how to pick between 2 and 4. So I don't think it's going to be 6. Again, assuming that it's a 2 odd and an even solution. So that would lead to something that is greater than. Okay? And if it's greater than, that means there can't be 1s here. And it could be that if there are no 1s in triangle and square, more than likely there won't be, or maybe there is a single 1 and circle is forced to be that. So if you have odd there, then you would have an odd and an even. And if you want something that is greater, how can you guarantee 1 is going to be 2 or 4? So I was thinking if triangle is a 3 and you want it to be greater, it would force you to pick 4 for square. So yeah, maybe. Now the question is, why the even here? How can you force square to be 4? Well, if there is a 1, then of course, you'd have to focus. If that's a 3 and that's a 1, the square would have to be even. Sounds plausible. So let me go ahead and try 3, 4, 1. And let me see. So I'm going to type it up, but let me quickly review. Yeah, that sum is even. I'm thinking it's going to be greater than 6, and there are no pairs. Yeah, so it doesn't contradict anything we already have established. And yeah, let's go for that. Okay, so yeah, primarily I did choose 3, 4, 1 because of, specifically criteria cards A and B. Perhaps that might be enough, and we can deduce that the sum is greater than 6. So let's go ahead and let's see. Let's go ahead and try A. Okay, so no, it is not 3. Okay, so we can say that triangle is either going to be less than 3 or greater than 3. Oops. So yeah, triangle is not equal to 3. So we can cross that out. Okay, well, that sort of derailed, I think, my proposal. Let's see. Well, yeah, let's see. What purpose would testing criteria card B hold? You know what? I think I'm going to test criteria card D again. I think that would reveal probably more information. So yeah, testing that again. Okay, so it is true that the sum is greater. So let me go ahead and cross out the equals portion. And now I know for a fact there can't be any 1s. Because if I want to guarantee a sum that's greater than 6, I cannot have any 1s at all. Okay, so that would mean that I don't have to actually test criteria card B, because at this point it would just give me an X, and that's not useful. I already know there are no 1s. So I may have to go to the next round. But let's see, what else can we conclude here? Is there anything else? So at this point, as I mentioned, I know I can't have all 5s, right? Again, because that sum total would be odd. But all the 2s and all the 4s are still there. Well, at this point, in order for the sum to be greater, I would have to pick 4, 4 for triangle and square. So I know if it is a triple digit, it would have to be all 4s as a possibility. Okay. Otherwise, what could it be? Yeah, I don't think I can make any other sort of... Okay, well, let's see. So we know the sum is greater than 6. Yeah, again, we got 4, 4. Yeah, I don't see being able to cross out anything. 2, obviously, it can't be like 2, 2 or 2, 3. or even 2, 4, but it could be 2, 5. It would be 2, 5, 4. Yeah, so at this point, yeah, triangle. Maybe the secret is in triangle. Could it be greater? And how would you choose it? Well, let's see. Perhaps maybe, let's see, let's list out. Oh, wait. Oh, yes, of course. Oh, yeah, wait. I think I may have made a mistake. I don't think I can cross out circle 1. I can only cross out triangle and square 1, since that's what retesting D established, that the sum has to be greater. So I apologize. I should not have crossed out the 1 in circle. I guess technically you could still have a 1 there. I believe that is correct. Okay. Yeah. Okay, so let's see. But I still don't think... Well, that's true. I guess I could test. Yeah, we know that it can't be 3 1s. So if we test criteria card B, if I get it wrong at this point, let's see. Yeah, you can't have 3 1s. Can't have 2s. So it's either there or not. So I think it may be helpful to test criteria card B, because if we cross it out, that would mean that we would have 2 odds and an even, and there'd have to be a 3 and a 5. Is that right? If there's a 1, great. It would have to be circle. And if there is no 1, I would have to have 2 odds and an even. Yeah, let's go ahead and test B. Okay, so yes, so basically the Turing machine is saying it does not agree that there should be a single 1. So yeah, so it does not like that 1. And so now we can cross it out. And I think, well, did that actually... Well, no, I guess technically 444 is still in the running. Yeah, I didn't think about that. And you could have 3 4s. Okay, well, yeah, that does it for this round. Let me, though, update my notes here, and we'll say that the solution has no 1 digit. Okay, so yeah, I did not like the fact of my single 1. Can't have 3, can't have 2. It didn't like the 1, so there are no 1s. Okay, yeah, I thought that maybe that would definitively let us know whether it's 2 odds and an even versus 4, all 4s. Okay, well, now we are done with this round. Now we're moving, again, we're going to have to try to construct a good third round proposal. And hopefully it won't be, we won't have to test too many criteria cards. Okay, so at this point, it looks like triangle might be a 2, maybe forcing square to be 5. That would be the most logical option. 2, 5, and then 3 in order to get that second odd. Okay. Because I think there's just way too many options if it's 4 or 5. So let's see. Yeah, let's go ahead and I'm going to say 253. 253. Yeah, that's 7. And it forces circle to be 3. Okay, so again, does it violate anything? Nope, that first digit is less than or greater than 3. That's true. There are no ones. That sum is even. The sum of the first two is greater than 6, and there are no pairs. Okay, so let's try that. And I think if we can show criteria card A to be 2, that would basically be it. So let's go ahead and test A. Okay, there we go. So 2 is less than 3. So let's go ahead and cross this out. And that would mean that, yeah, triangle is neither 4 nor 5. It's 2. And again, that would force square to be 5 because you want to guarantee the sum to be greater than 6. 5 would be the only possibility. And of course, that's a sum of 7. So you do need another odd that's not repeating. And the only one that's left is 3. Okay, so it looks like the solution is 253. And unfortunately, I still don't know of a good way to have, disqualified the all equal digit. Obviously, yeah, I'm not sure. Okay, well, I think we did enough reviews, so I feel pretty confident about that. So let's just go verify. 253 as our solution. So 253. Excellent. Now, how do we do versus a Turing machine? That is that we tested 7 criteria cards versus the original 6. So not ideal, but it's not. It's possible. So let's see. We did do C, D, E in the first round, and we did A, B, D in the second round, and then A again. Well, that's a lot to remember. So let's see. I think I got it. C, D, E, A, B, D. Oops. So C, D, E, and A, B, D, and B was incorrect. B, D, D was correct, and I think we got A correct. Missed it by 1. Of course, well, doubly, obviously they did it in exactly 6. It took me, 3 rounds and 7 questions. Well, that happens. So I don't know. Again, maybe I was just too stuck on the idea that it could have been a triple digit. Maybe I missed out on some simplification. I might have missed it. How about you? How did you solve it? What order did you pick for your criteria cards? And did you find any, sort of shortcut or, what criteria cards worked for you? Please add those to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.